Hi Pirates! Today we're going to go over our Chapter 7 review. I hope you're having fun with area, volume, and cross sections. Now for this first example, hopefully you've already graphed it either on your calculator or using your mental curve collection. You can use your calculator to find the two intersection points, or you can use good old Algebra 1. When we want to find the area, we're looking to find the space between these two functions. We're going to be measuring area vertically, so our height is going to be top minus bottom. As we accumulate the height, we are accumulating from -2 to 3. Our top function is the x minus our bottom function, which is the parabola x squared minus 6. We can type that into our calculator using our Math 9, and we get 125 over 6 units squared. Good idea. All right, for the next one, we've got y equals 4. We're now revolving it around a horizontal line. If our horizontal line is what we're revolving, and we have a vertical slice, we are using the disk washer method, which means we are perpendicular to our axis of revolution. We will find our volume by accumulating areas of circles. In this case, big R is going to be the distance from the axis to the outside function, which is our parabola. It's the larger space. I have a little r, which is the distance from the axis to the inside function. My volume is pi. Again, I've got x in my formula. I need x values on my integral. I've got big R squared minus little r squared. Be careful with how you type it in. It should be math frackable, and we get a final answer of 250 pi units cubed. Okay, so far so good. For the next one, we're going to revolve it around y equals -8. That is below the axis of revolution. So now all of a sudden my big R, my outside function, is actually line to axis, and my little r is parabola to my axis. If I'm subtracting a negative number, it's really addition of the opposite. Feel free to simplify or not. Be careful with how you type that into your calculator. We have volume equals pi. Again, still x values, big R squared minus little r squared. Surprisingly, through no plan of mine, we get the exact same answer. Okay, moving on to cross sections. If we want square cross sections, what I would recommend you do is draw a square. Again, the critical slice, the critical piece of information, is the same height that we had in our picture. So my top minus bottom measurement was x minus x squared plus 6. To find volume using cross sections, we want to accumulate our area formula. Area of a square is just side squared. And now when we plug that into our volume, we're accumulating same x values, our area formula. Do I need a pi in there? Nope, I don't, because there's no circles. It's math frackable. And again, we have units cubed. This is a volume measurement that we found. Last but certainly not least, we have a semicircle. I would encourage you to draw the semicircle first. My critical slice is my diameter. So again, that's where we're going to put the important measurement. Area of a semicircle is 1/2 pi r squared. Yes, you need to know that. Good old geometry. I've got 1/2 pi. Now this is actually the diameter that I was given. So I need to cut that in half to get my radius. Often we kind of simplify a little bit first. So this would really be 1/2 squared, which is 1/4. 1/4 times 1/2 is 1/8. And I get pi over 8, x minus x squared plus 6 squared. Okay, we plug it into our volume formula. Same x values. Now this one, if I bring the pi over 8 out front, is actually just what I had times the pi over 8. So 625 pi over 48 units cubed. I hope you enjoyed question 1. We'll see you for question 2.